Alright, for today's agenda, we've got a couple projects to work on, and neither of them are terribly big or terribly complicated, so I'm going to do both of them. One of them is going to be changing the optic on this thing. Got the SIG Romeo 1 mostly because it was cheap and I wanted to test the theory out. So I installed it myself. I did the cut myself, drilled and tapped myself, and installed the sight. Unfortunately, the sight isn't working anymore and I don't know why. I'm going to try and send it into SIG to see if they can do a warranty repair. It's not terribly old. I've only had this thing to the range 3 times and it's not working. So that's going to be one project. The other one, we're going to be changing the muzzle device on the Brownells BRN 180. So this is the same upper that you saw in the last video, but we're changing the muzzle device. Mostly because I don't want to use a 3-prong flash hider. Technically it's not legal in the area that I'm living in. We're not supposed to have flash hiders because, that hides the flash. Why would you want that? So I'm going to put a muzzle brake on instead. And that's project number 2. And we got a few parts in. Got the muzzle brake and a new optic. So I'm going to start with the rifle. We're going to put the muzzle brake on because it's the easiest. I'm going to set everything else aside for now. The muzzle brake, as it comes from the factory, is going to be covered in sticky oil grease stuff. Now I don't think this one has either a top or a bottom. It looks pretty symmetrical either side. So as long as the flats are at the top and bottom, we should be okay. Comes with some washers so you can get your timing right. And some thread locker, I assume. See enclosed instructions. There are no enclosed instructions. But changing out a muzzle device isn't that difficult, so we should be okay. First thing though, got to make sure that this rifle is not loaded, or we have to unload the rifle. And we do need to remove the lower from the upper. There we go. Gotta set the lower aside. I'll take the upper apart. And there is indeed nothing in that chamber. So we are golden, boys and girls. Not loaded. Now I do have this reaction wrench from Geisley, designed for the AR-15. You would insert this end with the flats into a vise of sorts. Your barrel extension is going to then fit onto this end, which is the same dimension as your bolt. And I'm pretty sure that this is going to work. Only one way to find out though. There we go. Yeah. It would appear that it doesn't work because this is not properly in line. The barrel seems to be sitting a little lower in the receiver than would be normal for an AR-15. It seems that the internal dimensions of this receiver are not exactly the same as an AR-15. Who'd have thunk it? You see in an AR-15 this would fit in a straight line, but in order to engage in the recesses, the barrel extension, we're at a slight angle here. I'm not sure if you can see that. We're not getting full engagement, so we can't necessarily use this because it's not going to give us something to talk again. So scratch that out here. Let's grab ourselves a wrench and wrench on it and see what happens. Oh, let me tell you, it's on there pretty fucking good. Okay, I'm going to fight with this off camera. Alright, I'm going to spend some time thinking about how to get this thing off because it just doesn't want to. So, for now, switch to the other project. I'm going to set this aside. We'll figure it out. Meantime, let's get this thing off and we'll put the new one on. These are snap caps. Slide is stripped, or field stripped. Now we got to take this off. And hope to God the threads are the same. Okay, so you'll see this cut that I made here. Nice and flat. One of the things about the USP is that the firing pin block, or at least the USP expert, the firing pin block will come through, or the hole for the firing pin block will come through, and the spring will come through the top here. That's normally held down by the adjustable sights that come with the expert, but since we put an optic on, it's going to be held down by the optic. So for the time being, set the spring aside. And here is the Romeo 1. Doesn't switch on anymore. Don't know why, it's just dead. Doesn't want to work. Set that aside. Future projects may include this. I guess if we manage to get SIG to fix it. But really, that side's just NFG. Here we have the Leopold Delta Point Pro. And just as I had feared, you'll see that these holes are not lining up quite right. So we need to make more of a cut onto the slide. By how much exactly? Yeah, about 1.5 millimeters. But more importantly, we want to see if these screws will work with the same threads that I put in here a little while ago. It doesn't seem like they will. Good news though is they appear to be a little bit bigger. 0.153. I don't know what the fraction of that is, as opposed to 0.134. So this is a good thing because we can recut the threads in here by making these holes a little bit bigger and then rethreading them. So we're gold on that front. I do know that the center to center on these holes is the same between the two sites. So we're good on that front. We just need to figure out exactly what threads are needed for the Leopold. It really doesn't protrude very far through, does it? But that's all that's needed. I'm okay with that. Okay, time to put this in the mold. Okay, before we go to the mold, what we need to do is figure out exactly how deep of a cut or how far we need to advance this cut. The way I'm doing that is I'm aligning the holes for each of the sites. You can see there. Yep, they're aligned. Handily, the back edge over here is the same distance on both of them. Well, the back edge is the same distance to the center of the holes on both of these sites. So that's pretty handy. So what we can do, squeeze the sides together on a flat surface, like this table. Squeeze them together and make sure they both flush to the flat surface. And with our calipers zeroed, we can use our depth gauge right here to figure out exactly the difference in distance between the front edge of both of these sites. Difference being 0.056 of an inch. So I'm going to tighten that down. And on the top of the slide here, I'm going to make a mark. I'll try to at least. Finish on these USPs doesn't want to mark up, so crap. So we'll use our layout fluid substitute and we're going to mark how much further we need our cut to be. And there we have our mark. Nice little line. I'm going to double check that and then we're going to the mill. So we've got the slide and our vise on the mill. Now we've got to set up our cut so that we only have to make as few passes as possible. And this is how I'm going to do it. Going to adjust it. By the way, this is a 2-inch indexable end mill, and I'm using this because it's got the tungsten carbide inserts. This is going to work better for cutting the hard steel of the slide as opposed to the hardened steel inserts or the hardened steel end mills that I would use on aluminium or plastic. I'm going to set my XY. I'm going to be doing cuts in this axis back and forth, as well as this axis up and down. First thing I'm going to do is I'm going to set my bottom, the absolute lowest that I can go, and I'm going to make sure that the lowest I can go is parallel or the same level as this flat right here. So I don't want to go any lower than the original cut that I had made. So we're going to touch down. Slide is not sitting square in our vise. Notice how we're not scratching over here, but we are scratching up here. First thing I'm going to do is make sure that we're clean inside of the vise, as well as on the bottom of the slide. Make sure there's no chips stuck under there, because that will put us off square. It's not something that we want. Put the slide back in, clamp it down. Don't want to go too tight because we don't want to put unnecessary stress on the slide. Bring our head back down. I'll start touching off here. Okay, we're still a little off square. Ah, the woes of the at-home machinist. Okay, what I'm trying to do, very slightly adjust the tilt of the column that's supporting the head. That's really the only way I can tram this in. Alternatively, I might be able to shim the bottom of the slide. This isn't exactly a Bridgeport, so these adjustments aren't terribly easy to make. And now we're dragging on the rear of the slide. So now we're tilted this way a little bit. Ain't that some shit? Okay, so all of those inserts were pretty much fucked. So what I did instead was just replace them. So we got a set of 3 brand new inserts to make this cut. Hey, 22 minutes of camming a fucking thing. Cramming in. Been at this for 20 fucking minutes now. Okay, that's about as close as we're going to get it. So, we've got our depth set. What I'm going to do now, raise this and bring it on over to where we want our cut to be. I'm going to try my very best to align the cutting edge of these inserts with the line that we made earlier. Touch down. Now you'll notice that the cutting edge on the insert doesn't go all the way to that line, but the leading edge of the insert does. So our cut is going to be almost rounded at the bottom because there's a different angle here. It's not a perfectly straight edge over here. It's got a slight geometry to the end of the cutting tip. Okay, so we've got our x-axis lined up. Y-axis is the way that we're going to cut. So we're going to cut front to back here because the line that we want to cut is in this orientation. Got our depth set. All that's left now to start cutting. Now you will notice because of the finish that HK puts on the slide here, as we start cutting, we're going to get a little bit of sparks. And that's only because of the chemical compounds in the finish tend to ignite or to spark. I'm just going to put a drop of oil on, try and minimize that. Okay, here we go. Now you will notice that I'm taking very light cuts. It's because this machine is very small and it's very flexible. Back and forth a couple times at the final depth. Just to make sure we've got a nice clean cut. Now you'll notice that this edge of this side, the finish is worn off. This side I didn't hit. That just means that the head isn't trammed in perfectly, but it's close enough, it makes no difference. Now we've got to check our work, take our sights, put it on, try and find the flashlight that we had in our hands 5 minutes ago. All I'm doing here is I'm just checking to see if we've got our hole alignment. Okay, we're really close, but we do need to move this edge just a little further in. Not by a lot, just a tiny little bit. Okay, I'm going to double check that. I'm going to leave the head where it is and just double check my work. See if that's got us the alignment that we need. Is that fucking flashlight again? Okay, looks like we're good. That teeny tiny little amount got us where we need to be. This cut is done. What we need to do now is find the appropriate tap to tap these holes. That just means putting threads in them. So, I'm going to figure some stuff out and we'll be back in a minute. Hopefully. Okay, so here we are 1 week later, still working on the USP. We got to the point where we made the cut. Off camera, I re-blued the surface that was exposed, just to put a nice finish on there, try and prevent some rust. And finally, we've got an appropriate sized twist, draw, and tap. So we can actually re-drill and tap these holes because, well, the screws are a little bit bigger for the Leopold. The screws being bigger means, naturally, we're going to have to recut the threads. So I've switched out the indexable animal for this chuck, and we're going to use the center finder to find the centers of these holes. And as you can see, we are not quite on center. So as I turn this with the center finder in the hole here, you can see this misalignment. That's telling me we're not properly centered. Let's try that. Centered this way, not this way. And that's kind of close enough. So we got our twist drill here. This is going to be the minor diameter for the screws, and once we get that through, we can then tap it. First thing I'm going to do though is double check the threads of the tap against the threads of the screws that mount the sight. Just make sure that we got them the same. And that looks like a pretty solid fit to me. Okay, so the thread pitch is correct. It's got to measure the outside diameter of the threads themselves. 0.153, 0.158. That should be fine. Well, it's an M4 thread, which means 4 millimeters by 0.7. Okay, so we're centered up. Now we've got to take the center finder out, put the twist drill in, and then drill the hole. Okay, looks like this thing's got a bit of a bend to it. Now we're going to lubricate it, get this thing turned on, keep it relatively low speed, and this is going to be the short hole, very gently make up cut. So you can see there's not a lot of material being removed here, if any at all. That's through. Okay. Now repeat for the other hole. So we should be centered in this axis You just need to adjust this axis. Since these two holes are perpendicular to the long axis of the slide, we should be okay on that. Doesn't look like we are though, which is interesting. But the mount worked just fine. And we had the seg sight in there. So a little lip on this side means we have to move that way. Still a tiny lip, even smaller, not much there. And flush. So we've got another little lip over here. Just using my nail to feel that that's flat. And there's no lip catching there. And that's going to be center. Yeah, that's good enough. Switch that out with the twist draw and we make the second hole. Get up to speed. And make our hole. And we're through. Now it's time to tap them. We'll grab our tap and our tap wrench. We're going to go to town. Okay, I got some of this stuff from Brownells. This is just tapping fluid. It's a lubricant for when you're making your threads. So since the tap is the thing that's going to be cutting the threads and it's going to be moving the chips, I'm going to lubricate that and then put another little drop on the hole itself. As far as I'm concerned, this is the thing that needs to be lubricated the most, because that's going to be doing all the cutting. Now I need to move the camera so that it's out of the way. But some of the old threads are still there. I'm just going to back it out until I catch the old threads. This should be a relatively easy cut because the old threads are there. This has been threaded before. Let's go forward, 360. Come back 180 to break the chip. And since this is a 4-flute tap, you really only need to go back 90. But we want to make sure that those chips are broken properly. And you can see that it's a relatively short hole, and we're pretty much already through. So I'm just going to run the tap most of the way down, just to make sure that those threads are cut nicely. That is a pretty shallow hole, but for mounting something as small as a tiny red dot sight, it's absolutely sufficient. Make sure we clean the tap off, get all those chips off of there. And we're going to lubricate it again. Not with that, with this. Going to lubricate it again. Make sure we get the hole and do the process over it. Now this hole is going to be a lot deeper. There's a lot more meat on this side of the slide. Going to have to cut and then back out to cut the chips a lot more on this one. And you'll be able to feel as you're tapping the hole when things start getting pretty tense. If you start feeling a lot of resistance, it's time to back up and break those chips. Start over. That's really kind of down to feel. So the last thing you want to do is break the tap inside of the hole. That's just no fun. So take your time, break those chips, and make sure you do it properly. Because again, the last thing you want to do, break that tap. They are pretty fragile. They're very hardened steel. And they do that to make sure that it can cut into what you're threading. And that also means you have to be very careful when you're threading. Because trying to extract one of these things, it's no fun. I haven't had to do that yet because I've been very careful, but it's inevitable. It's going to happen eventually. Hopefully on a project that isn't quite so critical. Just be extra careful and you'll be fine. The tap has now made it all the way through the hole. I was looking down underneath the slide from this angle and I can see that it's come all the way through. So we're gold. Now all that's left is to pull it out, clean up, and then mount the sight. Make sure to clean up after yourself. Before you put this tap away, you want to make sure that all the crap is off of it. You might want to reuse it later on down the road for something else. Be kind to yourself or the next guy. Clean up after yourself. And store it in its original packaging so that you know exactly what it is. So we've got our holes re-drilled, re-tapped. Slide is pretty greasy at the moment. It's got some crud on it. There's all the chips that came out of that hole. It's easy enough to brush out. You'll see what I'm saying over here. The one hole doesn't have a lot of meat to it. Not a lot to bite onto. And the other hole's got a lot to bite onto. So there's a lot of steel on this side, not so much on this side. But that's okay. Because if you have a look at how far the screws protrude on the sight itself, I'll show you right now. So at the bottom of the sight, the screws don't protrude very far at all. So that tiny little bit of metal that's holding these screws in, it's going to be just fine. And at the bottom of the vise here, you'll see, here's all the chips that came out of that second hole. So the tap was functioning perfectly well. It was cutting those chips, and as you reverse the thread to break those chips, it pushed them all down to the bottom, gets them out of the way, so that doesn't interfere with cutting additional threads. And it was a cheap tap too, so you don't have to have the most expensive equipment to get the job done. As long as the thread's right and you're careful, you'll be just fine. I'm going to switch back over to the table now and we can mount the sight. Okay, so here we have our slide, freshly molded, drilled and tapped. Here we have our sight. First thing I want to do is make sure that these threads are actually cut properly. I'm going to, just by hand, try and thread these screws in. It's catching nicely. It's threading. No problems here. Okay, these screws do come with thread locker on them, but it's dried and it's going to peel off. Pretty much just blue Loctite. I'm going to try and scrape as much off with my nails as I can, because while it's going to function the way it's supposed to, I just want a fresh layer on. So I got my own Loctite and it's blue Loctite, it is removable, but it's going to stop these screws from backing out. So remove what was there. We're going to redo the thread locker. I'm just going to grab a rag and all the excess nasty off. I do want to put a bit of ballast on this surface before we mount the sight though, just to protect and preserve, that kind of thing. Little dab will do you in this case. We don't need a lot. I'm just going to confirm again, these holes do line up, and they absolutely do, which is fantastic. Sight is mounted as far forward as we can get it. Next thing I'm going to do is find a bit that fits these screws. It's going to be a Torx head, and that's the one that fits. Number 24, T15. Get our screwdriver ready. I'll put a drop of thread locker on each of those. Okay, in goes the first screw. I'm not going to torque that down all the way just yet. And the second screw. I'm going to tighten that down, snug, and then a little bit extra. We don't want to make it too tight because we don't want to strip the threads that we just cut. Tight enough is tight enough. Use your judgment. I'm not going to go hog wild on this. Just enough that its sight doesn't move side to side, backwards, forwards. And we're going to trust in the thread locker to keep those screws from backing out. And that worked fine when I had the SIG Romeo installed on the slide. It should work fine in this case as well. And that's our sight mounted, boys and girls. Next thing is to put the battery in. Make sure you install it the right way around. And you can see we have a nice little red dot. That's pretty bright. Brighter max. There we go. It's in. It's working. The only thing that's left to do is take it to the range and zero it. Unfortunately though, because of the times and the things that are happening out in the world, taking it to the range is not possible at the moment because all the ranges are closed. So we're just going to reassemble and then hope for the best. And that's how to install a red dot sight on your pistol. Unfortunately, the USP line doesn't come with the cut from the factory because it is an older design, and red dot sights on pistols weren't a thing back then. That was a little bit of patience and the right tools, we can do it ourselves. Ain't that some? Quite a sight to behold. So that's that project done. This project I'm still struggling with. The original flash hider on the BRN 180 doesn't want to come off, and I'm trying to get in contact with the Brownells Tech Department, see what we can figure out, see if they have any suggestions for getting that thing out. So we got this one done, still stuck on the other one, and that's what I got for today.